The next topic is in this chapter inverse Laplace transforms. Okay, so I'm going to start with a simple example. Here is a simple example. H of s equal to 4 over s plus 1 s plus 3. Okay, this is a transfer function. We know that the numerator represents the zeros of a transfer function and denominator represents the poles of a function. Okay, now to find out, so this is in S domain, we need to convert this S domain equation into time domain equation. That's what the inverse Laplace transforms indicates. Okay, so inverse Laplace transforms basically useful to convert a function, S domain function or frequency domain function into time domain function. That's what it is for. So first thing we need to do is we need to decompose this given equation. So to decompose, find out how many poles are there. Here we have two poles. Those poles are s equal to -1, s equal to -3. It doesn't matter so I mean it doesn't matter what type of poles are these, but the order of the denominator. So here the order of the s is 2. We have s square if you multiply this. So based on this, we can decompose this into two separate functions. So the two separate functions, I'm going to separate them. A over s plus 1 plus b over s plus 3. These are the two separate functions. Okay, so this is the given transfer function. Now what I'm doing, I'm converting or I'm decomposing them into two different transfer functions, which is equivalent to the main transfer function. What is the advantage of decomposing this? Because once you decompose by using the Laplace table, we should be able to transfer that s function into time domain function. Now we need to find a and b parameters here. If this simple, it's a good idea to go with the substitution method. So how do you find the substitution method? So to find a, just put a equal to, write everything of the main equation other than the denominator of a. So the whole thing of the equation is 4 over s plus 3, because eliminate the denominator of a. Now substitute s equal to -1. Substitute s equal to -1. So if I substitute, so what I did, I make the denominator equal to 0. So that's how I got s equal to -1 here. So 4 over -1 plus 3, which is 4 over 2, which is 2. So a value is 2. Now I'm going to find b equal to, same thing, take the whole thing other than the denominator. So 4 over s plus 1. Now substitute s equal to -3. So it's going to be 4 over -3 plus 1. So 4 over -2. So -2. So a equal to 2, b equal to -2. So I have h of s equal to 2 over s plus 1 plus, or I can say minus, it doesn't matter, plus -2 over s plus 3. Okay, so how do I know whether I have the right numbers? You don't need to do it in your examples, but I'm going to do the Lcm method. I don't have any common least multiplier here. So s plus 1 over s plus 3, 2 times s plus 1 plus -2 times s plus, sorry, this is 2 times s plus 3 -2 times s plus 1. Okay, so I mean this is going to be multiplied with 2, this is going to be multiplied with -2. All I did, since I don't have any common multiplier in the denominator, this is how we're going to do it. I mean, the simple way of another example, if you have say 5 over 6 plus 7 over 11, something like this. So how do we add these two? It's going to be, since I don't have any common factor, we're going to multiply both in the denominator. So 5 times 11 plus 7 times 6. Okay, so that's how we do in a simple math. So that's what I did here too. Okay. Now if I do the multiplication, so 2s in the numerator, 2s plus 6 minus 2s minus 2 over s plus 1 and s plus 3. See, 2s get cancelled, 6 minus 2 is 4, so I will end up with h of s equal to 4 over s plus 1 and s plus 3. That's the given transfer function. So as I mentioned, you don't need to prove this. Okay, so all you need to do is separate them. H of s equal to 2 over s plus 1. I mean 2 defactor, decompose them, so we'll end up with 2 over s plus 1 minus 2 over s plus 3. Okay, now by using the table we can convert this into time domain, inverse Laplace table. So if you look at the table, we know that e to the power of at equal to Laplace transform of e to the power of at equal to 1 over s minus a. 1 over s minus a. So isn't this look like in this format? So can I change that? So can I write this as h of t equal to 2 times e to the power of, so if I have plus a here, it's going to be minus a, so here I have minus 1, so sorry, here I have plus 1, so it must be minus t. 2 times e to the power of minus t minus 2 times e to the power of a is here 3, so minus 3t. This is the inverse Laplace transformation. So we transferred an s domain equation into time domain equation. Okay, so first thing what we did, as I mentioned, you don't need to show me this equation. This is just verify whether I got the a and b values are correct or not. Okay, you don't need to show this in your solution. Let me go with another example here. Here is the next example. 10s over s plus 1, s plus 2, s plus 3. Okay, now what is the order of the denominator? I have s plus 1, s plus 2, s plus 3, so the order is 3. So for sure you will end up with 3 terms, s plus 1 plus b over s plus 2 plus c over s plus 3. Okay, now how to find a, b, c? Okay, the first method is always substitution method. I prefer substitution method. That's easy way. When the problems get complicated, we'll do it another way. Now substitution method, a, to find a, take the whole given h of s, given equation, other than the denominator of a. So 10s over s plus 2 and s plus 3, and then substitute s equal to minus 1. So it's going to be minus 10 divided by 1 and 2. So I will end up with minus 5. So s is minus 1 plus 2, which is 1, and minus 1 plus 3, 2. So a equal to minus 5. At the same time, b equal to 10s over s plus 1, s plus 3, substitute s equal to minus 2. So here minus 20 divided by, this is minus 1, minus 2 plus 1 is minus 1, minus 2 plus 3 is 1. So we'll end up with 20. 20 is b. And c equal to 10s over s plus 1, s plus 2, and substitute s equal to minus 3. So here minus 30 over minus 2 and minus 1, so minus 30 over 2, which is minus 15. Okay, now I decomposed the equation, given equation. Now h of s, I can write it as minus 5 over s plus 1 minus 5 over s plus 1 minus 20 or plus 20 over s plus 2, and c is minus 15 over s plus 3. Okay, now we can use the same transformation, e to the power of at. Laplace transformation of e to the power of at is 1 over s minus a, so it's going to be minus 5 times e to the power of minus 8. I mean, a is 1 here, so e to the power of minus t, plus 20 times e to the power of minus 2t, minus 15 times e to the power of minus 3t. Okay, this is the h of t, inverse Laplace transformation of h of s. Okay, thank you. I'll solve more examples in the next videos.